How do you find a final amount when the initial amount is increased by the same percentage multiple times? You multiply the growth factor by itself t times, then multiply the result by the initial amount. Let's take a look at an example involving a bank account. And to keep it simple, we'll disregard the currency. Say you deposit $1,000 into an account that offers an interest rate of 5% per year. This means that the amount of money in the account increases by 5% each year. You want to find out what the balance in the account will be after 3 years. These calculations become very time-consuming if you don't use the formula introduced at the start of this video. Let's take a look. The heavy lifting here is in having to calculate the final amount for each year separately, because the final amount one year is the initial amount for the following year. This takes a lot of time. Let's look at why. First, you need to find the final amount after year 1. 1,000 times the quantity 1 plus 0.05, which is 1,000 times 1.05, which equals 1,050. Now you have to find the balance in the account after year 2. In this case, the initial amount is the final amount from year 1. This gives you 1,050 times the quantity 1 plus 0.05, which is 1,050 times 1.05, which equals 1,102.5. Finally, you have to find the amount in the account after year 3. Again, the initial amount is the final amount from the previous year. So you have 1,102.5 times the quantity 1 plus 0.05, or 1,102.5 times 1.05, which is equal to 1,157.625. As you can tell, this was a very time-consuming process. But doing things faster and smarter is always nice. So, let's show how these calculations can be done a lot faster by introducing a unit of time into the formula. Here it is. The variable y is the final amount. The variable a is the initial amount. 1 plus r is the growth factor, where 1 is a percentage representation of the initial amount, and the variable r is the rate of growth, which indicates the percentage increase. The newly introduced variable t is the number of units of time. In other words, how many times the growth factor is multiplied by itself. The period represented by t could be years, months, hours, minutes, or any other measure of time. In this case, t represents the number of years your money is in the bank account. Now that we have added a variable for units of time to the equation as an exponent, it is now known as the exponential growth formula. To find the account balance after 3 years, you first insert the values for the variables you know. The initial amount A is 1,000, the amount you initially put in the bank. The rate of growth is equal to 0.05, because the interest on the balance is 5% every year. Lastly, you want to know how much money will be in the account after 3 years, so t equals 3. Cleaning up the expression then gives you 1,000 times 1.05 to the third power. 1,000 times 1.05 to the third power is equal to 1,157.625. That means that after 3 years, the amount in the account is expected to be 1,157.625. Notice that this amount is the same as the one you got earlier using the very tedious, slow method from before. This time, you got the answer much faster. So, both methods yield the same answer, but using the exponential growth formula will help you get the answer a lot quicker. Imagine how much time you'll save with this formula when you're calculating interest over a 10 or 15-year period. When an initial amount is increased by the same percentage t times, you multiply the growth factor by itself t times, and then multiply the result by the initial amount.